Next problem. What happens to the centripetal acceleration of a body if we double its orbital speed? What happens to the centripetal acceleration of a body if we double its orbital speed? Okay, so we can write the centripetal acceleration. So that is A is equal to V square by R. That is a centripetal acceleration. So let me write what is A1. A1 is equal to V1 square by R. What is A2? A2 is equal to, here the orbital velocity is doubled. That is V2 square by R. Here what is V2? V2 is equal to 2 times of the V1. So 2 times of the V1. So 2V1 by square by R. So what is 2V1? Here what is 2V1 all square? That is 4 into V1 square by R. Okay, but what is the V1 square by R? That is the previous centripetal acceleration, that is A1. So A2 is equal to 4 into A1. That means the centripetal acceleration is increased by 4 times. So the centripetal acceleration is increased by 4 times if we double the orbital speed. So that is the answer. Now we have this next one. Two particles of equal mass are revolving in a circular paths of radii r and 2r with equal speed. What is the ratio of their centripetal forces? Two particles of equal mass are revolving in a circular paths of radii r and 2r with equal speed. What is the ratio of their centripetal forces? Okay, here we are asked to find the ratio of the centripetal forces, and we are given the mass. They both are moving, both have the same mass, and both are moving in a circular path of different radii, that is r and r 2r, but with equal speed. So we can use the formula F is equal to mv square by r. Okay, here F1 is equal to two particles of the equal mass, so m is the same, and v is the same, so v square by the radius. Then what is the centripetal force of the second particle? Here F2 is equal to, here again mass is the same and the velocity is also the same, mv square by, instead of r here the radius is 2r. So that is equal to 1 by 2 into mv square by r. So what is mv square by r? That is the centripetal force for the first body. So half into F1. So let us write what is the ratio of their centripetal forces, that is F2 by F1 is equal to 1 by 2, or F1 by F2 equals 2 by 1. Therefore, the ratio F1 is to F2 equals 2:1. That is the ratio of their centripetal forces, the first and second particles. Okay, the next one. Determine the angular velocity of the minute hand of a clock. Determine the angular velocity of the minute hand of a clock. That similar problem we are already done in the case of a second hand of a clock. Anyway, we can do. What is the angular velocity? You can first write the formula. Angular velocity is omega is equal to angular displacement by the time. Okay, here the minute hand. The minute hand covers 2 pi radian in how many seconds? That is 60 into 60. So angular velocity omega is equal to 2 pi divided by 3600. So you can complete the calculation. So what is the answer? 0.00174. That is that much radian per second. So that is the angular velocity of the minute hand. Now, find the angle through which a cyclist leans when he rides through a curved path of radius 50 meter at a speed 10 meter per second. Find the angle through which a cyclist leans when he rides through a curved path of radius 50 meter at a speed 10 meter per second. Okay. We can have the formula for the optimum speed. That is optimum speed v is equal to square root of rg tan theta, or we can have tan theta is equal to v square by rg. Okay, so this is the formula. So let us check what informations are given. Here the radius, the r is equal to 50 meter, that is in the SI unit, and the speed v is equal to 10 meter per second. Okay, so we can substitute the values here and find the value of tan theta first, then from that we can find the value of theta. Okay, here theta tan theta is equal to 10 square divided by radius is 50 meter, the g is equal to 9.8. So let us check what is the value of tan theta. That is 0.20408. Okay, so therefore theta is equal to tan inverse 0.20408. So you can calculate that one. That is 11.5 or 11.53 degree. So this is the angle that the cyclist should lean when he rides through the curved path. Okay. Now move to the next one. A meter gauge railway track is constructed around a curve of radius 400 meter. A meter gauge railway track is constructed around a curve of radius 400 meter. What super elevation must be given to the outer rail in order that the train may move round the curve at a speed 72 km per hour, avoiding lateral thrust? Okay. What super elevation must be given to the outer rail in order that the train may move round the curve at a speed 72 km per hour, avoiding the lateral thrust? Here we can have the banking of rails. Okay, here there is a curve in the railway track. Here the radius of the curve is 400 meter, and we are asked to find the super elevation. Super elevation. We have the formula super elevation. Tan theta is equal to h by d. Tan theta is equal to h by d. Okay. Here h is the super elevation. D is the distance between the two rails. Okay. Now the radius is 400 meter, and the velocity with which the train has to turn the curve is the optimum speed is 72 km per hour. That is V is equal to 72 km per hour. That we should convert into kilometer per second. That we can use the simplest formula, that is 72 into 5 by 18. That is so that is 20 meter per second. And here, what is the distance between the two rails? Here, that is a meter gauge. So we are already familiar with the different types of the railway tracks. That is a narrow gauge, meter gauge, standard gauge, and a broad gauge. Here, the meter gauge means the distance between the two railway tracks is 1 meter. Okay, so here the distance between the two track is from that. Here d is equal to 1 meter. Okay, so what is the formula for the super elevation? We have, let me do the proof again. Tan theta is equal to h by d. Similarly, the tan theta is also equal to v square by rg. Let us equate this one. H by d is equal to v square by rg. From that, the h super elevation is equal to v square d by rg. Okay, so that is the formula that we have to use in this situation. So let us substitute the values. H is equal to v. What is the value of v? V is equal to 20 meter per second square. That is 20 square. And d, since it is a meter gauge, the distance between the two rails is 1 meter, and the radius, that is 400 meter into the g 9.8. So that is equal to, that is 400 divided by 400 to 9.8. So that is 1 by 9.8. 1.98, that is equal to 0.102. That is the meter, that is the super elevation. So that is equal to 10.2 centimeter. Okay, so this is the required super elevation that must be given to the outer rail.